Now let's see how we can use these testing signals. First of all, I'd like to clear all the command window, the figures, and also the workspace. You can use the clear to clear the workspace, CLC clear the command window, and CLF to clear the figures. So let's just define the time, the transfer function for G2, and also the feedback response, the closed loop transfer function for G2. And we also define for the system G3. So let's look at how I define the system G3. So instead of using TF, you can use ZPK. Z stands for 0, P poles, K is the gain. So in this case, Z is empty square bracket. P, I define it as 0, -3, and K is 6. So what happened is that, so you have no 0, you only have plain gain, K is equal to 6, and you have two poles at origin, S equals to 0, and at -3, so S plus 3 here. So you can use the impulse function to find the impulse response. Again, you can find individual response by using the impulse G2, for example. So you have the impulse response for system G2, or you can find the impulse response for both G2 and G3 systems in one plot. So the blue line is the G2 system, G3 depicted by the red line in this plot and on the same plot. Similarly, you can find for the step response for G2 individually. Yeah, this is the step response for system G2 and for G3 as well. For RAM function, there is no RAM function in MATLAB, so you can type help RAM, it gives you RAM not found. So the workaround to use the RAM function is, I'll show you two examples. The first one is use the lsim function to generate RAM response. So let's define U equals to T. So you have the lsim, so try to help lsim. Okay, what's the definition? So you have the lsim and you have the system. In this case, our system is G2 closed loop, G2CL. And you have U and you have T. T is the time vector, and U, the metric U, it has many columns as input in systems. So example, in this one, you want to have a RAM function. So basically you plot U against T here. So let's see what happens when we run this command. When you run the lsim, you specify on the y-axis as a y and a t, a matrix as a t. T here depicted as a time. So what happened is that, yep. So the red line is the basically RAM input. It's the other way around. So it should be TU, and we have TY. Let's try again. Yep. Okay, the blue line is the RAM input. Okay, so RAM input, and we have the RAM response of the G2 system. You see here. Okay, and also we can use a step function to generate the RAM response. What you need to do first is you define the S as the transfer function. So you have S, and you want to generate the first one is the RAM input. So you have YSTS equals to step 1 over S. This is the RAM input. And next one is to generate the RAM response of the closed loop of the system G2. So you specify that as the step G2 CL over S. Because the RAM input, it should be 1 over S square, right? So in this one, step is 1 over S. So when you define the input, the system is 1 over S, so you have 1 over S square. Same goes for here. And you can next plot the response. Yeah, you get similar response as previously. You use the lsim function. So it's up to you either to use the modified step function, or you can use the lsim function to find the RAM response to the system. Similarly, you can try on another system. For example, there's G3.